Welcome to everyone. In this session, we will learn about dielectrics. What is meant by dielectrics? The dielectrics are nothing but insulators. Insulators means non-conducting materials. A dielectric is a non-conducting material. Underline, it has no free electrons. I will discuss about this later. Dielectrics has no free electrons and the electrons in a dielectric are bounded within the atoms. To understand this, I am going to recall few points about atoms. In an atom, protons and neutrons are at the center core of an atom. That means concentrated at the nucleus. Center core of atom means what? That is nothing but nucleus. In an atom, protons and neutrons are at the center core of an atom. That means concentrated at the nucleus. Electrons are at their respective orbits and revolving around the nucleus. In a conductor, there are number of free electrons present in the outermost orbit of an atom in that conductor. Conductors means having free electrons in their outermost orbit. In case of insulator means there is no free electrons in their outermost orbits because of all the electrons in that atom according to the electron configuration bounded by the nucleus. The electrons which are present in that outermost orbit, that electrons only free electrons, that free electrons only carry the electric charges in that conductor. This type of materials are called the conductors. For example, copper, silver, human body, these are the examples for the conductors. In case of insulators, there is no electrons in their outermost orbit of an atom, so there is no free electrons, then the insulators do not conduct or carry the electric charges. This type of materials are called the insulators. For example, glass, mica, etc. The dielectrics are made up of either polar or non-polar molecules. Underline this. Dielectrics are made up of either polar molecules or non-polar molecules. Let's go study about non-polar and polar molecules. Non-polar molecules. A non-polar molecule is one in which the centers of positive and negative charges are coincide. As a result, it has no permanent electric dipole. What is meant by that? In case of non-polar molecules, the center of positive charge and the center of negative charge coincide with each other. That is why the non-polar molecules has no permanent dipole moment. Before learn about the reason, we want to remember the electric dipole moment. Let us consider two point charges plus q and minus q are kept at a distance 2d apart. Two equal and opposite charges separated by a small distance, that is 2d. The magnitude of the dipole moment is given by the product of the magnitude of any one of the charges. Magnitude of any one of the charges means, that is plus q, in other words minus q, and the distance between the two charges. Product of magnitude of any one charge and a distance between the two charges give the magnitude of an electric dipole moment, that is nothing but P is equal to Q into 2D. But in the case of nonpolar molecules, the centers of positive and negative charges are coincide. There is no separation of the charges. Charges separated by a small distance means, that is electric dipole, then only the electric dipole moment will be present. In case of nonpolar molecules, there is no separation between the charges. So that the nonpolar molecules do not have permanent electric dipole moment. That means, that is why no permanent dipole moment for a nonpolar molecules. Example, hydrogen molecule, that is H2, and oxygen molecules O2, etc. In addition, when an external electric field is applied, listen carefully. When an external electric field is applied for the nonpolar molecules, the centers of positive and negative charges are separated by a small distance. Once again, we consider a nonpolar molecule. In the absence of external electric field, the center of positive and negative charges coincide with each other, but when we will apply an external electric field to that nonpolar molecule, which induces dipole moment in the direction of the external electric field. That means there is a separation between the two charges. Then the dielectrics is said to be polarized. See here. In first case, in the absence of external electric field, that means without external electric field, the center of positive and negative charges coincide with one another or each other. But in case of external electric field, that is with the external electric field, the positive and negative charges, especially center of positive and negative charges, separated by a small distance. Then dipole will occur, and then it has dipole moment. What will happen in case of external electric field? The nonpolar molecules are polarized. About the polarization, I will discuss back. Next, polar molecules. In polar molecules, the centers of the positive and negative charges are separated even in the absence of an external field also. Note down this. In case of polar molecules, the centers of the positive and negative charges are separated even in the absence of an external electric field. Then that molecules will act like electric dipole, then automatically the polar molecules will have a permanent dipole moment. We will see. Polar molecules have a permanent dipole moment, but due to the thermal motion, underline this, due to the thermal motion, varying the temperature of the polar molecules, the direction of each dipole moment is oriented randomly. What is meant by that? Indefinite directions. In case of non-polar molecules, the center of positive and negative charges coincidence with each other, so that equal and opposite point charges do not act like an electric dipole, then it do not have a permanent dipole moment. But in the case of polar molecules, there is a separation between two equal and opposite charges, that means center of positive and negative charges, by small distance, in the absence of external electric field also. But one thing we want to notify here, due to thermal motion, the direction of each dipole moment is oriented randomly. See here. Polar molecules are randomly oriented in the absence of external electric field. See here, negative and positive charges separated by a small distance. Now this system acts as an electric dipole, so it has permanent dipole moment. But we will take more number of dipole in the dielectrics. The direction of the dipole moment are varied from one another. That is why we are telling, in the absence of external electric field, polar molecules are randomly oriented. Hence, the net dipole moment is zero. Directions of dipole moments are indefinite, so hence the dipole moment zero in the absence of an external electric field. Example, H2O, one of the polar molecule, because of H plus and O minus separated by a small distance. Like that, N2O, HCl, these are the examples for polar molecules. In these molecules, the center of both positive and negative charges separated by a small distance. When an external electric field is applied, the dipoles inside the polar molecule tends to align in the direction of the dipole moment. Hence, a net dipole moment is induced in it. We are going to apply an external electric field, means the direction of these electric dipoles are aligned in the same directions. Then the dielectrics is said to be polarized by an external electric field. What is meant by polarization? I notified In case of non-polarized and polarized molecules, in the presence of external electric field, that specified molecules are polarized like that. Then what is meant by polarization? That means in the presence of an external electric field, the dipole moment is induced in the dielectric material. In the presence of external electric field, the dielectric medium dipole moment is induced. This phenomenon only known as polarization. In other words, polarization is the total dipole moment per unit volume of the dielectric. For most of the dielectrics, the polarization is directly proportional to the strength of the external electric field. What is meant by that? The strength, we will increase the strength of the external electric field means the range of polarization also increased. That means the alignment of the electric dipole moment also increased. External electric field oda strength increase பண்ணும் பொழுது polarizationும் increase ஆகும். Because of both are directly proportional to one another. In the equation form, polarization P vector is directly proportional to E external vector, external electric field in the form of vector. Now I will introduce a constant here, that is psi E. Therefore P vector is equal to psi E into E external vector. Here psi is a constant, that is the electric susceptibility. That electric susceptibility will give the characteristics of each dielectrics. Underline this. About this susceptibility we learn more in our third lesson. Thank you.